Naval aircraft, we are operating in international airspace in accordance with international law. We will maintain the same flight direction and altitude. In short, it is still too young, 7 hopes, because the electronic system does not bring advantages. The Z-10 pilot decided to yaw close at a distance of only 500 meters, hoping that a close approach will turn the situation. At this distance, he can clearly see the U.S. gunner on duty next to the ALQ-99 caliber. Not fired yet, but the Rande message is too clear. While the Z-10 is only equipped with 23mm cannons and weapon pylons, basically it does not carry torpedoes or specialized anti-submarine systems. Clearly at a disadvantage in a direct confrontation scenario, the difference begins to show clearly. The Z-10 pilot deploys maneuvers to suppress sharp turns, to force the opponent to defend. Before this victory continuously swoops left and right, nose up, and dives. However, each maneuver causes Cho to lose speed sharply. At the same time, the fuselage must endure G pressure near the design limit, while the Romeo, based on the proven Blackhawk frame, maintains superior stability. Result, the Chinese pilot pushes himself into a state of overload, while the US side hardly needs to react. At this point, the sensor combat balance is completely tilted in the US's favor. The NAR-47 missile warning system on the Romeo records and stores all the maneuver characteristics of the Z-10, maximum rotation speed of approximately 20 degrees per second, and the ability to climb 12 meters per second. These data will be used to program precisely for U.S. missiles in missions to intercept similar helicopters. In other words, Z-10 is writing its own 7-defeat scenario. At the same time, the freer camera on Romeo records images in the high-resolution infrared range. If it contains all the hotspots, the exhaust reaches approximately 450 degrees Celsius. Plus, movement is approximately 180 degrees Celsius. These thermal characteristics allow U.S. engineers to pinpoint the area to aim for the thermal seeker, making them a weak point in a real combat scenario. In reality, the Chinese pilot now accidentally becomes the target. Experiment instructions on how to disable his own helicopter if he believes their forces on the aircraft can turn the situation. Further developments will prove otherwise. The 23mm cannon of Z-10 has limited effectiveness, designed primarily to destroy targets ground at very close range. When confronting a maneuvering helicopter at a distance of a few hundred meters, the chance of hitting the target is almost negligible. On the contrary, GAU-21, equipped on MH-60R, has an effective range of nearly 2,000 meters. Using explosive piercing ammunition capable of penetrating the Z-10 cockpit with current manufacturing standards and configuration, Z-10 is unlikely to withstand this type of fire. In this situation, Z-10 is operating in a light configuration without carrying torpedoes or specialized anti-submarine equipment. The priority target is to hang around for a long time and show off, rather than face-to-face confrontation with a platform optimized for anti-submarine missions. Like Romeo in Z-10 cockpit, warnings activated simultaneously. Signal lights covered the screen, signaling an emergency. Control commands became sluggish. The fuselage shook violently, signaling mechanical overload. Chinese pilot clearly felt the instability. The control stick seemed to be fighting the plane itself, but retreating meant facing disciplinary action. He muted the warning and forced the machine to perform one more maneuver. Finally, in that effort, the Chinese pilot repeatedly tried to lock the radar, but each attempt became valuable data for experts. Electronic warfare U.S. system on Romeo recorded everything from each frequency jump, from pulse pattern, to every attempt to penetrate the jamming layer, forming a profile. Details of the radar's operating mechanism, Z-10. When Chinese pilots switched to laser indication via the photoelectric system, sensor on Romeo not only detected but also accurately identified the type of device and the software version control. This means the U.S. can develop countermeasures not only for the Z10 facing, but for all vehicles using the same architecture. A single encounter